Okay, and good morning, very good morning to all students, those who are attending the online class today. So today we are discussing applications of colloids, the part of nanomaterials. So colloids may play a significant role in the nature and in our daily life. So colloid may play a very significant role in nature in our daily life. So let's see the applications of colloids. So first one is in medicines. So colloidal medicines are automatically more effective as they are easily absorbed by the body. So these colloid medicines are
Good morning, sir.
very good morning, Nana. So these colloidal medicines, they having a very effective and easily absorbed by the body. So because so these medicines competitively is more effective. So many medicines are emulsion. Some of the major antibiotics like penicillin and streptomycin are injected in the body in the form of colloidal salt, so that they would be absorbed by the body easily. So what we say, so some of the medicines in the form of colloidal salt, when we inject such type of medicine to the patients, so the body of patients should easily absorb by such type of medicines easily. So that's why colloids, they may play a major key role in the medicines. So next see the sewage disposal, the disposal of waste materials. So sewage water contains impurities like dirty particles of colloidal size dispersed in the water or mud. So they're having n number of colloidal impurities were dispersed in the water. So these colloidal particles are also they having some of the charge. So by method, so electrophoresis method, we use it to remove the colloidal impurities in the sewage water. So that's why here we using some of the method, electrophoresis method, use it to remove the colloidal impurities. Here we use metallic electrodes which are fitted with a funnel, and we maintain at a high potential difference. So when we maintaining the potential difference, the charged particles of impurities are present in water, so that particles present in water will migrate the oppositely charged electrodes, which results in the coagulation. So we use electrophoresis method to removal of colloidal impurities present in the sewage water. So next we see the next one is purification of water. So here uh, the water having a number of impurities, they may having salts. So that's why here we use the precipitation method to remove the impurities present in the water. So after removal of impurities, so we get the pure water. So here also we are using electrolytes like alum. So these electrolytes will use it to precipitate the impurities present in the water. So after precipitation of colloidal impurities in the water get neutralized by the aluminum ions. So these residue were settled down in the bottom of the beaker. So after settle down, we use some of the filters and we remove the residues. So we get pure water for our drinking purpose. So next, so in the cleaning purpose, so we are using colloidal nature containing soap solution. So generally soap solution is colloidal in nature. So which removes the dusty particles either by adsorption or by emulsifying the gas grease matter sticking to the cloth. So we apply soap solution to the cloths. So emulsifying the or absorption the process. So which is sticking to the cloths and we remove the dust particles in the cloth. So we use colloid as a cleaning actions of soap. So next, so formation of delta. So here the river water may having some of the charged colloidal impurities like clay, sand, and many other impurity materials which are present in the river water. So coming to seawater, the seawater may having huge number of impurities in the seawater. So in that some of the components have charges. For example, the components which are present in the seawater like calcium, magnesium and sodium. So they may having the positive charge. On the other hand, the river water may having negative charge. So these positive and negative charges will get neutralized. So they forms delta. Whenever they get neutralized, that means coagulate seawater in the suspended colloidal particles. So ultimately settle down. So where the river joins the sea, in that content center, they settle down of the particles, colloidal particles, suspended colloidal particles were settled down where they joins. So this is called formation of delta. So which the water deposits different materials where the river joins the sea. So that is known as colloidal particles were formed. So due to the causes of some suspended particles in the water. So that is known as formation of delta. So next we see the smoke precipitation. Smoke precipitates are actually electrically they having some of the charged colloidal particles. So here the smoke is also having some of the colloidal particles so which having some of the charge particles of present in the air, so which forms precipitate. Let's see here, quadral precipitators, which is based on the principle of electrophoresis. So in the electrophoresis, so we use the metallic electrodes. By using metallic electrodes, the particles which is present in the air, that means smoke, which get precipitated by the oppositely charged electrodes. So by using electrophoresis method, we remove the smoke colloidal particles in the air. So in this case, the nuisance of smoke by big industrial sites can be avoided by using the smoke precipitations in the surrounding unit. So next, one of the application, that is the photography. A colloidal solution of silver bromide in gelatin. A colloidal solution of silver bromide in gelatin is applied on glass particles or celluloid films or paper to form a sensitive plates in photography. So here we use the colloidal solution. We make a sensitive plates in the photography. So next, here is the some of the applications of colloid. Artificial rain. So artificial rain can be caused by spraying oppositely charged colloidal dust or sand over a cloud. So in this artificial rain, so when they causes, so by spraying oppositely charged colloidal dust or sand over a cloud, so the cloud water particles present in the cloud will neutralize and coagulate to form a bigger water drops, causing artificial rain. So next, one of the best example of colloidal, why we say, which is a very significant role in our daily life in the nature. So one of the best medicinal application of colloidal solutions in the making of artificial kidney mission. Artificial kidney mission. The human kidney purify the blood by dialysis. So generally dialysis patients, so failure of their kidneys, so they are using artificial kidney mission for purify their blood. So that is called dialysis through the natural membranes. So during this process, so some of the toxic waste products such as uric acid, so that means urea passes through the membrane, and colloidal sized particles of blood proteins are retained. So in the kidney failure is leads to the contamination of blood with poisonous waste. So whenever the kidney causes failure means, so when their blood with poisonous waste, so some of the contaminants were present in their blood cells, so which causes the kidney failures. So sometimes we taking our generally, which is depends upon the food habits, so contaminated food habits, impurities present in the food, whatever it may be, we take in our daily life. So especially water, so untreated water we are using for drinking purpose, so sometimes may causes kidney failures because of the untreated water. They may having n number of impurities. So same in the food habit also, some of the components are cannot dissolve in our digestive system. So such type of particles which contamination of blood, or sometimes some of the poisonous wastes, so these present in the blood and which causes the failure of kidneys. So such type of problems are purely reduced by using the artificial kidney mission. So here the patient's blood can be cleaned with providing a artificial kidney mission. In this, they improve the blood and it is made to pass through a series of cellophane tubes surrounded by a washing solution in water. So the toxic waste chemicals, so that means urea and uric acid, so which diffuse across the tube walls and the washing solutions were get we removed. So that's why the purified blood is transferred to the patient. When we remove the contaminants and toxic waste by the method, so that is called cellophane tubes, we use it to remove the contaminants present in the blood. So when we remove the impurities, so after the purified blood is transferred to the patient, so it is one of the main application of artificial kidney mission to save the life of humans across the world. So that's why we say the colloidals they may play major key role or significant key role in the daily life and the nature. So in the field of medical medicines, so if a person suffering from acidity, for example, some of the people, a number of people are nowadays they are suffering the acidity. So a suitable medicine containing an anion exchange in the form of colloidal, so which neutralize the acidity in the humans. So these are the applications of colloids. They may play major key role in our daily life. So next here we see the rubber industry. So latex is a colloidal solution of negatively charged rubber particles. So rubber industry, the formation of gel-like latex colloidal solution as a negatively charged rubber particles form latex rubber by obtaining coagulation. So next we see the smoke screen. So here warfare, some of the wars, the smoke precipitates we are using by the colloidal dispersion of certain substances in the air. So the that is colloidal solutions which forms the smoke screen. So next one of the application, the sky is in blue color due to the scattering of light by colloidal dust particles in air. So why the sky is in a blue color? So which indicates that wherever the presence of colloidal impurities, dust particles in air, so by scattering of light through these particles, which gives a blue color of the sky. So next one, so blood is a colloidal solution and the stoppage of bleeding on applying a ferric chloride solution is due to the coagulation of blood forming a clot. So these are the applications of colloids. So next we discuss the applications of nano materials. So what are the applications? We are using nano materials. So here some of the applications we are discussing here in the nano materials. So in general catalysts. So in general nanomaterials have high surface area and hence they provide a higher catalytic activity. So it is possible to synthesize a metal nanoparticles in the solution in the presence of surfactant. So for examples, so we manufacturing the metal nanoparticles in the presence of surfactant solution, which forms highly oxidized nanodisperse films, which forms highly oxidized nanodispersed films. So these films may having the greater catalytic activity. So they forms uniformity in their size and chemical structures. So that's why they're having higher catalytic activity. So this allows more uniformity, already discussed. So which in turn leads to greater catalytic activity. So which protect some of the few byproducts also. So that is the use of catalysis in nanomaterials. So let's see some of the examples of metals we are used as a catalysts. So the one of the best example, rhodium hydrazole, have been shown to be a effective catalyst for hydrogenation of olefins dissolved in the organic phase. So rhodium nanoparticle catalyst is used for hydrogenation of olefins dissolved in the organic phase. So next one, palladium colloids have been shown to catalyze reactions in reduction of carbon-carbon multiple bonds in presence of formic acid. So it is also used in reduction of nitriles and nitrates. So these are the some of the catalytic activities when we synthesize the nanoparticles we are using in the catalysis. So next, medicine. So nanoparticles, they may have a vital key role in the medicines also. So let's see what are the significant roles played by the nanomaterials. So nanomedicine is the medicinal use or molecular sized particles. So because of all nanoparticles, they may having the smaller size. So that means a nano level. So 1 to 10 nanometers level. So these particles, they may have the significant role in the human body when they delivered as a medicine to the human bodies. So let's see here, the molecules having a small size of particles. So to deliver drugs, heat, light, or other substances to specific cells in the human body. So nano level particles as a drugs, which the substances which deliver the drug medicine uh, to the specific cells in the human body where the human body get injured, where the causes a disease in the human body cells. So we inject the nano medicines, so which passes to the specific area only. They can treat at the particular specific phase when they enter into the human body. So see here, because of their small in size, they based upon the small in the size, they have access so many areas in the human body. So that means they process any part of the human body because of which is having a smaller in the size. So they have the potential to detect disease and deliver the treatment. So that is the main advantage application of nanotechnology were used in the medicines. So that is which is easily enter into human body, which passes any part of the human body or any cell when they go and they detect the disease and deliver the treatment at a particular cell when they cause damage in the human body. So next here, the nanoparticles can deliver drugs directly to the diseased cells in our body. The nanoparticles which deliver the drugs directly diseased cells in our body, either as the drug itself or as the drug carrier. So whatever it may be, which deliver the drug at where the part which causes disease or which causes damage in our body easily. So here, the nanoparticles may be used to effectively to deliver the genes to cells. to deliver the genes to cells, so to treat cancer, so as well as in vaccination by dividing the particles into cells, which cells are known as nanocells. So these are injected into cancer area and they recognize the cancer cells. So that is the main application of nanotechnology, which is used in the medicines. So in sometimes, in some cases, the biomedical metal alloys may aware of out of the lifetime of the patients. So, but here the nano materials increases the lifetime of the implement medicinals. So nanocrystalline zirconium is an attractive material for the implements. Here, the nanocrystalline silicon chloride is a candidate material for artificial heart values due to its low weight. So this is one of the best application of nanocrystalline silicon chloride carbide is used as artificial heart values due to its having low weight. So these are the best applications in the nanotechnology in the medicines. So let's see next sensors. So sensors are used to measure the efficiency of any equipment or fields, so whatever it may be. So they're having various parameter sensitive changes in the various parameters they have designed to measure. So sensors are employ their sensitivity to the changes in various parameters they are designed to measure. So that is the one of the best applications we are using sensors nowadays. The measured parameters including the electrical resistivity, chemical activity, magnetic permeability, thermal conductivity, so and the capacitance. So one of the typical applications of sensors are smoke detectors, ice detectors on aircraft wings. So this is one of the best applications of sensors we used in the aircraft wings to detect the smoke and ice detectors when the airplanes are flying over the sky. So we can detect the climatic conditions of sky where they move. They can identify the smoke where is a clearance of the dots. So automobile engines performance. So automobile engine performance also we determine by using the sensors. So that is the best applications of sensors we are using nowadays. So for example, a carbon monoxide sensor made of zirconium oxide it is a chemical stability of detect the presence of carbon monoxide levels in the atmosphere. So carbon monoxide sensors used making of by the material zirconium oxide used to make carbon monoxide sensors, so which is used to detect the presence of carbon monoxide levels in the atmosphere. So these are the best applications of nanotechnology in the society and our daily life. So here some of the nanoparticles, so they're having a significant applications already we discussed. We are using as a catalyst. So they have some of the magnetic nanoparticles potential applications of some of the storage and drug transport we discuss. So coming to the nanowires, so nanorods and nanowires. So we are using silicon nanowires, a source photoluminescence. So zinc oxide nanowires which exhibits ultraviolet and ultraviolet laser at room temperature. Semiconductor nanowires used making of field effect transistors. So some of the other applications we discuss, sunscreens, cosmetics, so coating of surfaces, hard cutting tools, fuel cells, so batteries, so catalysts. So a number of applications of nanotechnology nowadays. So one of the best, we are using the lithium batteries. So in the lithium batteries, the act of storage of device in the lithium batteries, so it's due to the very lithium atoms stored for every 6 carbon atoms of nanotubes, and hence it is used to store and the charge carrier the lithium lithium batteries. So these are the applications of nanotechnology we are using our daily life and nature. So in this topic, we completed the nanotechnology and their applications. So next class, we are going to be discuss some of the our civil related topic like building materials. Building materials. Next class, we discuss building materials. So which is also a very useful subject to the civil students. So next class, we discuss the building material.